Exercise 10.2. Question number 1. Compute the magnitude of the following factors. Factor A equal to I plus j plus k, and factor B equal to 2i minus 7j minus 3k. So magnitude of factor A will be root 1 square plus 1 square plus 1 square, because the scalar component of the vector A are 1 1 1. So magnitude of the vector A is root 1 square plus 1 square plus 1 square equal to root 3. Magnitude of vector B, the scalar component of the vector B are 2 minus 7 minus 3. So magnitude of the vector B will be root 2 square plus minus 7 square plus minus 3 square is equal to root 62. Write two different vectors having same magnitude. We have to write two different vectors having same magnitude. So we can write vector A equal to I plus j plus k. So its scalar component are 1 1 1. Vector B is I minus j plus k. Scalar component of this vector are 1 minus 1 1. So these two are different vectors because their scalar components are different. And then you see the magnitude, their magnitude will be same. Magnitude of A equal to root 3, magnitude of B is also root 3. So A and B are two different vectors having same magnitude. Question number 3, write two different vectors having same direction. So we have taken A here, I plus 2j plus k. If we multiply this vector by 2, we will get another vector B, 2i plus 4j plus 2k. So their direction will be same. We have multiplied this factor by 2. Factor B is 2 into vector A. So their direction cosines, if you find the direction cosines of vector A and B, then you can see their direction cosines are same. So their directions will be same, but the vectors are different. Question number 5. Find the scalar and vector components of the vector with initial point 2 1 and terminal point minus 7 minus 5 7. So let A be 2 1 and B be minus 5 7. Then vector AB. So vector AB will be x2 minus x1 whole into I plus y2 minus y1 whole into j. So first you have to write coordinates of B. B is minus 5 minus 2 whole into I plus 7 minus 1j. Minus 5 minus 2 is minus 7i plus 7 minus 1 is 6j. We have used here vector joining 2 points formula. Okay, x2 minus x1 whole into I plus y2 minus y1 whole into j. The scalar components of the vector AB will be minus 7 and 6, and the vector components are minus 7i and 6j. Find the unit vector in the direction. Question number 8. Find the unit vector in the direction of vector PQ, where P and Q are the points 1 2 3 and 4 5 6 respectively. Given P 1 2 3 and Q 4 5 6. So first you find the vector PQ. Use the vector joining 2 points formula. X2 minus x1 whole into I plus y2 minus y1 whole into j plus z2 minus z1 whole into k. So 4 minus 1 whole into I plus 5 minus 2 whole into j plus 6 minus 3 whole into k. So this is equal to 4 minus 1 equal to 3, 3i plus 3j plus 6 minus 3 is 3, 3k. So magnitude of the vector PQ will be square root of 3 square plus 3 square plus 3 square, because scalar component of this vector are 3 3 3. So magnitude of PQ is root 27 is equal to 3 root 3. Therefore the unit vector in the direction of vector PQ is equal to the vector divided by its magnitude. The vector PQ is 3i plus 3j plus 3k. divided by its magnitude. Magnitude is 3 root 3. Now you can split it into 3 fractions, then, or you can take common 3 from the numerator. You can take common 3 cut, and then you can split it. You will get 1 by root 3I plus 1 by root 3j plus 1 by root 3k. Question number 10. Find a vector in the direction of vector 5 minus j plus 2k which has magnitude 8 units. Consider this vector as vector A. Let vector A be 5 minus j plus 2k. First, you find the unit vector along the given vector, along the vector A. So, unit vector in the direction of vector A is a cap equal to vector A by its magnitude. So, the unit vector along the vector A will be 5 minus j plus 2k by root 30. So this is the unit vector along the vector A, but we need a vector whose magnitude is 8 along the given vector, along the vector A. Magnitude of this vector is 1 because this is the unit vector, and direction of this vector is along the vector A. So if you multiply this vector by 8, you will get a vector of magnitude 8 units along the given vector. So we multiplied this unit vector by 8. So 8 into a cap is equal to 8 into this one, unit vector. So this one equal to this. Next, number 12. Find the direction cosines of the vector I plus 2j plus 3k. Direction ratios. What are the direction ratios? The direction ratios of the vector is 1, 2, 3. The scalar components. The scalar components are the direction ratios 1, 2 and 3. These 3 are the scalar components. So direction ratios are 1, 2, 3. Therefore direction cosines will be 1 by root 1 square plus 2 square plus 3 square, comma 2 by root 1 square plus 2 square plus 3 square, comma 3 by root 1 square plus 2 square plus 3 square. That is 1 by root 14, 2 by root 14, 3 by root 14. Question number 13. Find the direction cosines of the vectors joining the points A and B, directed from A to B. So first you find the vector AB. Use the vector joining 2 points formula. x2 minus x1. First you have to write coordinates of B. x2 minus x1 whole into I plus y2 minus y1 whole into j plus z2 minus z1 whole into k. That is minus 1 whole into I plus minus 2 whole into j plus 1 minus 3 whole into k. So we have got minus 2i minus 4j plus 4k. So direction ratios of the vector AB are minus 2, minus 4 and 4. The scalar components. The scalar components are minus 2, minus 4 and 4. So these are the direction ratios of the vector AB. 2, minus 2, minus 2, minus 4 and 4 are direction ratios. Therefore direction cosines of vector AB are minus 2 divided by root, that is magnitude of the vector, minus 2 by the magnitude of the vector, minus 4 by magnitude of the vector, 4 by magnitude of the vector. So we have got minus 1 by 3, minus 2 by 3, 2 by 3. Question number 16. Find the position vector of the midpoint of the vector joining the points P and Q. Suppose position vector of the point P be vector A. Position vector of P suppose denoted by vector A. Vector A equal to 2i plus 3j plus 4k. So this is the position vector of the point P. 2i plus 3j plus 4k is the position vector of the point P. The position vector of the point P, suppose vector A, denoted by vector A. Position vector of the point Q. denoted by vector b. Suppose 4i plus 1j minus 2k. So a and b are position vector of the point p and q. Then the position vector of the midpoint of pq. Then the position vector of the midpoint of pq is equal to a plus b divided by 2. Midpoint formula. So substitute the vector a and b. Add 2i plus 4i is 6i. 3j plus j is 4j. Plus 4k minus 2k is 2k. We have taken out 2 common. 2 cut. So we have got 3i plus 2j plus k.